Good morning. I'm Bryan McQuade. I'm a software engineer at Google. I work on making the mobile web faster and better. And today I'm going to talk about building instant mobile web apps. So we'll take the next 30 minutes to cover two topics. The first will be I'll give an overview of the process my team actually took to optimize one of the apps I work on. And then the second half, we'll sort of take from that some learnings or some generalizations and best practices that hopefully you can take with you to make your mobile apps faster. OK, so our goal specifically, more precisely, is to render app content on the phone in a second. So from the time a user sort of clicks a link to the time they actually sort of start to see content on your phone and are able to interact with it should be about a second. And this 1 second target actually comes from some work linked here at the bottom by Jacob Nielsen. Hopefully you can see that. That talks about some different thresholds of human perception, where sort of behavior changes. And that 1 second boundary is interesting because that's the point at which a user will start to sort of disengage with the activity they've initiated. They'll start to think about doing something else. And so to keep the user engaged, to keep them wanting to use your app, we want to try to deliver that content as quickly as possible, ideally within that roughly 1 second boundary. So a lot of what I'm going to talk about is sort of focuses on this concept of the critical rendering path, which you may have heard Ilya talk about or others talk about. At a really high level, the critical rendering path is sort of the sequence of resources that need to be loaded and parsed, usually JavaScript and style sheet resources, that prevent content on the page from actually rendering from the screen, right? So actually, it's easiest to sort of explain, I think, with an example. OK. So here along the top, we've got kind of a timeline that shows how an example page that I'm using for this example renders over time. Out to 20 seconds on a mobile device, so we have a performance problem here. And the question becomes, well, why is it so slow, right? Why is it taking 9 seconds to render anything to the screen, and why does it take 20 seconds to sort of finish rendering? And that's what the critical rendering path sort of tries to answer. So if we have an example network waterfall here, we can kind of walk through and try to start to make sense of what this critical rendering path is all about. So obviously, we start by loading the HTML resource. That comes back with some content. It might have a style sheet and a script resource. And so at this point, we have sort of, like I said, the critical path includes usually script and styles. These resources block the browser from actually painting content to the screen. So while a style sheet is pending, the browser is going to wait for that style sheet to load before it actually paints any content to the screen. So we can't paint anything until these resources finish loading. Imagine that we send out the request for both of those. The response comes back for the JavaScript at 9 seconds. And at that point, we can begin to paint something to the screen, right? It may not be the content the user actually wants, unfortunately. That's sort of at the end. But we've sort of started to paint. And then from there, imagine the JavaScript resource adds a CSS resource to the DOM, a style sheet to the DOM. And so now that's on the critical path for sort of subsequent paints. Once that loads, we can see, we can paint a little bit more content. The style sheet maybe had some stylings for the footer. Additionally, we've loaded, say, a second JavaScript resource from that first JavaScript resource, and say that's used to actually render the sort of main content in the screen. And so that now has to load, parse, and execute before we can actually see any content on the screen, or I'm sorry, see the final content. And then finally, around 19 or 20 seconds, all of that finishes, that whole sort of process of these things loading in the browser finishes, and we can paint the sort of finished content to the screen and show that to the user. So the critical rendering path tries to sort of focus on the most significant resources that cause render blocking and explain sort of why we see these delays. This becomes especially important on mobile, where we have these very high network round trip times, and loading extra JavaScript and CSS resources ends up having a significant cost. So now we'll focus more on sort of thinking about optimizing the critical path. We know here that we've got this really long critical path of resources. This is just a toy example. But so the question becomes, well, how do we actually address and optimize that? And I'm going to talk about the process my team went through about a year ago to do just that for one of the apps I work on, PageSpeed Insights. So PageSpeed Insights is a tool you can use at developers.google.com/pagespeed. This is a tool where you can enter a URL into the box here. We go off and we render the page in a headless browser. We analyze how it loads. And we come back and give you a sort of prioritized list of recommendations to make the page load faster. And about a year ago, we had this problem. Well, we started to think about, OK, how do we make this page really fast on mobile? We knew we weren't doing great. But the first thing we did was we wanted to see exactly how poorly we were doing, right? And so what we saw really surprised us. It was worse than we expected. Now you can see where the example comes from. It took 9 seconds to render anything at all, but it took about 19 or 20 seconds on a 3G connection on an iPhone 4 in this case to render what the user actually cared about, which was that initial text box that they could use to interact with the app. And so, 20 seconds. Our target is 1 second. We've got something, a really significant problem here, and we knew we needed to really sort of rethink a lot, or try to figure out what we had missed, right? This app was reasonably fast on desktop, but on a high latency mobile connection, it just took way too long to load. So we started to look at the markup. We saw we had some render blocking resources in the head, but this isn't all that uncommon, right? You see this in lots of apps, so there's nothing that really stood out here as being particularly costly. So we went back to our timeline. Then we looked at a network waterfall, right? And you can see we load about 25 resources here. And the question came up, OK, well, we're loading all these resources, but which of these resources are actually contributing to making the page slower? Which of these are on sort of the critical rendering path, right? And so one of the things that PageSpeed Insights actually does today is it can tell you which resources are on the critical rendering path. And so we can go here, we can click through, and we can see, we've got these JavaScript resources, these CSS resources that are on that critical rendering path, that block rendering of content on the screen, and then use that to go back to our waterfall and start to focus on which resources actually block rendering, right? So now we have about a dozen resources to focus on, and we're able to focus more precisely on what are the render blocking effects of these resources, and then how do we address those. And so we can begin to sort of match up here, right? We've got some content that loads before this sort of 9-second first paint. We can start to notice, OK, well, which of those resources are blocking that point, and I'll get into that in just a minute. But this was sort of the starting point for us, was sort of looking at this and figuring out, OK, well, how do we optimize the critical rendering path for this page? And so, at a high level, we felt like we had sort of two problems here. One was that we had a bunch of render blocking JavaScript and CSS loaded in a way that blocked any content at all from rendering on the page, right? So this block of JavaScript and CSS here, which was declared in the head of the HTML, all had to be downloaded, parsed, and executed in order for anything at all to render on the screen, right? And as we know, mobile networks have really high latency, so downloading additional resources has a pretty significant, pretty high cost. All the while your users are looking at a blank screen, waiting and wondering if your app is working, thinking about transitioning away to do something else, right? So for us, and I'll show in a little more detail in a minute, what we concluded we needed to do was basically eliminate all of these resources from being render blocking. And that amounted to doing two things, which we'll dive into. Loading our render blocking JavaScript asynchronously, and then really thinking about, well, what is the minimal amount of CSS we actually need to render this app, and loading that in a blocking way, but making sure we weren't loading any more than we needed in a render blocking way. And then, right, and so recall this is the screenshot that sort of was associated with that point in the page load. The thing to note here is that we hadn't actually rendered the content the user really cared about, that text box to interact with the app yet. So the second issue was we were actually rendering that sort of critical content, the text box, that the user could use to actually analyze a page using a JavaScript resource, right? We had to download a large chunk of JavaScript, download, parse, and execute that JavaScript before we actually rendered that, using JavaScript to construct the DOM. And so this added another roughly, 10 seconds of latency here before we could get to this point. So all in all, we had sort of at a high level, these two problems. And so we sat down and we tried to sort of address these things. The thing we did for this was we realized, well, most of the content, we're rendering it with JavaScript, and that's fine and great, but it just wasn't performant. And so what we did is we inlined that initial view, right? So or I should say, we put the initial view's HTML markup directly in the HTML, no longer depending on JavaScript to actually render that, which allowed us to, just present that to the user that much faster without having to wait for that render blocking JavaScript to load. So I just wanted to show a quick before and after. Here's that HTML markup for the original page that took 19 seconds, at least part of it. Right? We've got our render blocking JavaScript in the head. We've got some markup for the content, but we don't have, you'll notice, the input box. Right? That was rendered with JavaScript, so some of that comes later. The sort of after case Here we've got a slightly different markup, right? First, we've got an inline style block that contains the CSS we need to style the content in the initial view, so we don't have to go to network to download additional style sheets, which will incur additional mobile network round trips, which are significantly slower or significantly slow down the page load. And then, as I mentioned, now we've made sure that all the markup we need to render this sort of above the fold content is directly in the HTML. We're not using JavaScript to render any of this content. And then finally, because we're including all the markup we need to render the initial view directly in HTML, we can load our JavaScript asynchronously because we don't need it to render, so we don't want it to block rendering of the initial presentation. So that at a high level was the process we went through. And so the question is, how did we do? Did we actually speed the page up? So here's the waterfall for the original page. We've got about 25 resources in total. And then here's the waterfall for this sort of rewrite that was focused on delivering a really fast experience on mobile. And you can see we've got about 20 resources now, right? So we had 25 before, 20 now. It's not really significantly different if you look at the total waterfall size, total number of requests, right? But I think what's really important here is looking not at the total number of requests, but the relative size of the two critical paths between the critical rendering paths between the two pages, right? So in the old example, we had a bunch of resources. Here, we've got everything we need to render the initial view in the HTML payload. So the critical path, the critical rendering path, is this one HTML resource, and we can render much more quickly than in the original case where we had a dozen resources. So we often talk about, well, okay, reducing requests is sort of a goal and with performance and with optimization, but I think what's more important is to think about reducing the number of requests on the critical rendering path. That's really where you will see your big returns. So let's do sort of a side-by-side, before and after. So the optimized case, we start to render in about 1.5 seconds, and we're completely done at 3 seconds. All the images, everything have come back. And recall the original case, we're still waiting, right? We can't actually really interact with the app even at this point because we don't have the text box, right? So we were able to reduce the, render time down from about 20 seconds down to 1 or 1.5 seconds, right? So we more or less accomplished our goal. So that's the process we went through, and now I'm going to spend a little time talking about the process of optimizing your app's content. So what did we learn? What are the general best practices there? How can you deliver this instant experience for your users on mobile? So the first thing we learned, or the first thing we sort of identified as an important best practice, is to load scripts asynchronously, right? So don't load scripts in a way that blocks rendering, because on mobile networks, with the high latency, high round trip times, each additional resource you load in the critical rendering path pushes out the time the user has to wait, to sort of start interacting with your app, pretty significantly, right? So here we've got your sort of standard page, script source equals all.js in the head, right? And we've got the content right beneath it. The browser receives that at the same time, probably, as the script, but it can't show it to the user until the script has finished downloading, parsing, and executing on the mobile device, which introduce really significant, additional render latencies for the user, right? And so what do we do? In the best case, you can take advantage of the HTML5 async tag, which tells the browser, yes, I need this script, right? So I need to load this script, but it's not, you don't need to sort of execute it in line at the point where it appears in the document. Execute it sometime later when it finishes downloading, and then go ahead and just proceed parsing the rest of the document and render that content to the user as quickly as you can, right? So this gets scripts out of the critical rendering path, which is a really important thing to do. So I'll say there are some subtleties here. It's often not quite as easy as just dropping the async tag in there. If you use document.write in your JavaScript, this is a really dangerous thing to do. And there are other sort of subtleties that I'd be happy to talk about at the sort of session, and I guess it'll be 45 minutes. So second, render the initial view server-side as HTML. You'll recall we had about 6 seconds of render blocking JavaScript and CSS, but then we had 10 seconds to load that final JavaScript resource, download, parse, and execute it before the app finished rendering, right? And the problem was we were loading this big JavaScript bundle whose job it was to actually construct the DOM, right? So we had to go to network in order to create the DOM that the user would see. And this is just, unfortunately, an inherently slow process on mobile. Rendering client-side, so let's talk about. So what do we mean by server-side rendering versus client-side rendering? So client-side rendering, you're using JavaScript, right, to actually render the content in the document, right? So here we load app.js. The DOM itself doesn't really contain any markup. It doesn't contain markup that you can see on the screen. It's just sort of got a placeholder div, and then when app.js finishes loading, we might get something like this that actually constructs the DOM, once that resource finishes loading, right? By contrast, server-side rendering, everything that we need to display in the initial view is present right in the HTML markup, and so no additional resources are needed, right? As soon as that HTML comes back, we can render that to the screen, and the user sees it as quickly as possible, right? So this is just on mobile especially, this is just a much more performant approach for the initial view. So certainly, once the app has finished loading and the user's interacting with your app, they're changing the way the content is presented, right? Maybe they're navigating through a menu. Certainly at that point, it makes sense to use JavaScript to construct your document. But for that initial view, you should do as much server-side rendering to HTML as you possibly can. So we found this to be true, but we weren't the only ones. Twitter also encountered the same, or came to the same conclusion. So they wrote a blog post about a year ago where they talked about this. In 2010, they'd released new Twitter, where all the rendering happened on the client, right? And they talked about, that allowed them to do some interesting new things, but it came at the consequence of significant sort of regression in sort of actual client-side render time, right? So in 2012, they wrote this blog post where they talk about taking back control of front-end performance by moving rendering back to the server. And what they found, is that page load times dropped really significantly, right? So it wasn't like 10% or 15%, it was 1/5 of what they were previously, right? So this was a really big thing for them. And in order to deliver that instant experience on mobile, it's pretty much a requirement that you render that initial view server side. So Twitter wasn't the only organization to sort of come to this conclusion. Airbnb had a very similar conclusion in a blog post earlier this year. They said, under their old design, the external JavaScript files had to download, evaluate, and execute. Only then would the app sort of discover, oh, the user's intent was to do X. It would call it to the API, which was additional network requests that sort of became part of that critical rendering path. Here we are on a mobile connection, which has really high latency, which led to, for them, a time to content, right? So a time until the user could sort of get the content that they wanted of upwards of 10 seconds in sort of, in bad cases. So then they switched to server-side rendering, which, by the way, they open sourced the infrastructure they use for this, so it's worth a look at this blog post. When they moved to serving the initial view as HTML generated on the server, it felt 5 times faster. So similar conclusion, right? Twitter, 1/5. Here, Airbnb, 5 times faster, right? So in my opinion, if you want to deliver a truly instant experience, and it's, there's a trade-off, right? You really need, so if you want to deliver that instant experience on mobile, you really need to be server-side rendering that initial view. Loading JavaScript to create the initial presentation is just going to be too slow on mobile for it to be an instant experience, right? And we saw Twitter and Airbnb both had really dramatic speed reductions as a result of adopting this technique. So I would say, when choosing a JavaScript framework, you want to look for a framework, ideally, that supports server-side rendering, right? Airbnb talked about the one they open source. Not all the JavaScript frameworks out there today do support this, but if you're using one today that you do like that doesn't support server-side rendering, you should push on the development team or pitch in and help out to make it easy to do that as part of using that framework, so you can take advantage of this automatically. So the third area I want to talk about is minimizing render blocking CSS. And this is, I think this is the topic we get the most questions on. So I'm going to go through a couple common questions here. The first of which, people say, well, what do you mean CSS is blocking? Why is this part of this blocking critical render path? JavaScript blocks, yes, but what do you mean CSS blocks? And it's correct that JavaScript blocks DOM tree construction, right? JavaScript blocks the parser, but style sheets block render tree construction, right? So ultimately, in order to lay out in Paint, we need the style sheet to have finished loading. And what your users care about is content painted to the screen, right? So for them, JavaScript is style sheets are render blocking, right? So it's important to sort of keep this in mind, right? If you load a large style sheet in the head, that's going to delay the time it takes to paint content to the screen. CSS is render blocking. So what's critical CSS? What is this? We talk about this concept of critical CSS. You may have heard it, sort of goes along with the critical rendering path. And how do I identify my critical CSS? So critical CSS, you can think of as the minimal CSS you need to actually sort of position and style content in the initial view of your app, right? So everything you need to present that flash of unstyled content for the content that you display initially to the user. The idea here is that because we know CSS is render blocking, we want to minimize the amount of CSS that we serve up to the user in order to minimize the sort of size of the critical path and get the content to display as quickly as possible. So identifying critical CSS, I'll talk about this. People often ask the question, well, I have all this CSS, I need all of it. What do you mean critical? How do I know what's critical and what's not? So again, critical CSS is that needed to position and style content in the initial view. So imagine we have this alert CSS rule, and then we've got this markup served up in the initial HTML, so it's going to be visible in the initial view that references that rule. We expect it to look like this on the page initially, right? We expect it to have their proper stylings. A good way to ask yourself, is this critical CSS or not, is to ask, well, if I took this rule out of the payload, right, would my initial view, would the content I serve to the user initially look correctly? And in this case, obviously, if we took that rule out, it would sort of get the default stylings and look totally wrong, right? So clearly, we need this CSS to style content in the initial view. Thus, it is critical CSS, and we want to serve it up early and in a render blocking way. So imagine we changed our HTML markup there. So you can see before it was span class equals alert. Now we decide, OK, we don't really want to mark hello world as an alert. It's just a normal snippet of text. We want it to be styled as such. At this point, so imagine, though, that we do use the alert class later in the app, right? Like imagine your users interacting with the app. They try to upload a video. It fails. You want to show an alert at that time. So we do need it, but we don't need this rule as part of the initial view. At that point, right, it's not part of the initial view, and so it's no longer sort of critical. And you may want to think about loading that later in the app lifecycle in a way that doesn't block the initial view. So one more bit. I think this is actually this is somewhat subtle, but probably the most important thing when we talk about critical CSS. It's critical, the critical CSS is the CSS needed to position and style the content in the initial view, right? So oftentimes we inline data URIs into our CSS, the goal being, OK, let's reduce the number of requests that my page makes. I can serve the image separately, or I can inline it right into my CSS. And interestingly, what we are doing when we inline these data URIs for images is we're basically promoting the image from being non-render blocking, right, not part of the critical render path, because images by default, obviously, you need to download the image to render the image itself, but images don't block rendering of other content on the screen. When we inline it as a data URI here, we've basically promoted it to being render blocking, to being a part of the critical rendering path, and we're making that critical rendering path that much longer, right? And so, data URIs too, they tend to be quite big, right? So here's our markup. So, if you look at your CSS and you're using this technique lots of sites do, you'll notice probably the majority of bytes in your CSS files may actually be from these inline data URIs. And what you're doing is you're increasing that critical path length pretty significantly and actually causing users to have to wait to see any content at all on the screen as a result. So you'll actually render the other content on the screen more quickly if you just switch back to that, either CSS sprite with the external file reference, or if you're using something like Speedy where spriting doesn't really bring you any benefit, just keeping each image asset separate, reducing the size of the CSS, reducing the size of your critical rendering path, and making the page load that much more quickly. This is pretty easy to test out. Create a simple page, inline a bunch of data URIs in a style sheet, create a second version of that page, use the technique here where you've got a separate image asset. Make sure there's some non-image content on the page, right? So put some text in there, whatever it may be. And then compare the two in web page test. Do a video comparison on a 3G network, and you'll see that when you inline data URIs into your style sheet, you're blocking rendering of all the content on the page, right? You're blocking the text, whatever it may be. So on mobile, again, where downloading additional content in the critical rendering path is expensive, I encourage people to not take that approach, except for maybe very small data URIs, right? So I would say that large data URIs, inlined in render blocking CSS are actually harmful for render performance, and I would avoid using that approach. So then a couple more questions. Okay, so I've identified my critical CSS, I've removed my data URIs, I made it nice and small. How should I load that critical CSS? So there's two ways to go about this. In PageSpeed Insights, we actually inline the critical CSS as a style block inline, so keeping that critical rendering path as short as we can, right? We don't want to go back to network to download an external style sheet in our case, because that incurs additional network round trips, which can add anywhere from 500 millis to maybe a second, depending on how it's loaded, of time the user's staring at a blank screen, right? So for us, we felt like the best approach was to inline the CSS needed to style the initial view directly in our HTML payload. But I wouldn't say that's necessarily a requirement. I think it's still perfectly reasonable to load that critical CSS resource, as long as the critical resource is small, in the head as an external resource. The page will be slower for people who don't have the resource in cache, because now they have to go to network to download that additional resource. But you get some other benefits, right? You're reducing byte sent on the wire for repeat views because once it's in cache, the user doesn't have to download it again. You may introduce a faster full cache experience for repeat views. It really depends. It's not guaranteed by any means. It's sort of a little counterintuitive. You would think, well, the HTML payload is smaller, so the page should load faster. But it actually depends. It's not necessarily the case. But in any case, either of these approaches is reasonable, and it really just depends. You're making a trade-off. Do I want the fastest performance, in which case you want to inline, or do I want a little bit perhaps more maintainable approach, in which case you could keep it external, and pay a little bit of a performance penalty for that. So things get kind of fuzzier the further along we go here. So the last bit, once we've loaded our critical CSS, now we've got this other CSS needed to style other parts of our app. How do we load that in a way that doesn't block rendering of the page? Unfortunately, today, there's not a great simple, straightforward technique. Like we have with script, we have async, right? It's a really easy, first-class feature of the platform. The same does not exist for style sheet. Any style sheet found in the document by the parser will cause the rendering engine to say, okay, I'm going to wait and not paint anything until I finished fully downloading this style sheet. So you can't just throw link rel style sheet href equals non-critical CSS in the footer of your HTML. The parser will find that, and as soon as it does, if it hasn't painted the content above yet, it'll say, whoa, I'm not going to paint anything, even the markup above that, until that finishes downloading. So you have to be careful here. In the meantime, so what we want is this lazy load attribute, and that's coming soon. Some Chrome engineers, IE engineers are working together on a spec. And what that says, basically, it's similar to async. And it basically says, I need this resource. It shouldn't block rendering. It shouldn't block onload. Load it, and when it's available, I'll make use of it. In the meantime, we don't have that today. It's coming. It's being spec'd. There are a couple ways you can sort of work around this. You list it here, request animation frame, so you sort of wait for the first paint. You could load the resource in a hidden iframe. You could actually load it as JavaScript. I've seen people do this, right? JavaScript has async, right? So you can load a CSS resource as JavaScript. As I say each of these, I'm sort of, part of me is feeling not great. This is really not the kind of APIs we want for this kind of thing. But fortunately, the lazy load attribute is coming, and that'll be the right thing to use once that's shipped. Right, so some high-level recommendations for render blocking CSS. How are we doing on time? A couple minutes. Right, avoid inlining data URIs, right, keep them external, keep the CSS as small as possible. Critical CSS, what that is, keeping that in mind and making sure you're focusing on only delivering that. But, all this said, right, and if you're sort of hearing me talk about this critical CSS and I have to load some early and some late and, that sounds like a lot of overhead. The good news is if your total CSS is reasonably small, like if it's under, say, 15K compressed, right, which might mean 45K uncompressed, it's probably small enough that you can just treat it all as critical. Just, don't worry about partitioning out. It's only when it becomes really big that you don't want to load all of it in a way that blocks rendering anything at all to the screen, right? So the common case, I hope, is that your CSS is already small, and you just load that up front and don't worry about this concept of non-critical CSS. If you do have a lot of CSS, you want to load that in a render blocking manner. We talked about sort of the two techniques for that, and then load the remaining CSS in that non-blocking manner using, for the time being, one of those request animation frame or whatever it may be techniques, longer term using that lazy load attribute. So just to summarize really high level, the things that we found are really important. Eliminate render blocking JavaScript, right? So load JavaScript asynchronously, get it out of the critical rendering path. So design your apps with that in mind, right? Don't depend on JavaScript having to load synchronously in order to render your page. And along those lines, render the initial view to HTML, right, on the server. So don't use JavaScript client side to render the initial view. It's an inherently slow process. We saw Twitter had problems, performance problems with this, Airbnb. My team had the same issues. And then finally, serve up as little CSS as you need to render the initial view. Be mindful of, just how much you're serving. And largely, you can accomplish that by just not inlining large data URIs into your CSS. I think if we stop doing that, I think our CSS size, for the most part, will become manageable and will be reasonable to load in a render blocking way. So that's everything.